In Chapter 2.3, we're going to be looking at graphing linear equations in slope-intercept form. This is the equation for slope-intercept. Y equals mx plus b. The m in this equation represents your slope. The b in this equation represents your y-intercept. If you can know those two things, then you can graph a line pretty easily. Okay. So the first thing I'm going to do a few of these, but I'm not going to do the same examples in the book. But example 1, let's graph something relatively easy here. Let's do y equals 2x plus 1. Okay, and you don't have to do this every time, but I'm going to label my slope. My slope is 2. My y-intercept is 1. And that comes from this number here, 2, and this number here, 1. So since I have those two things, I can draw a line with those two things pretty easily. So I'm going to put maybe 4 marks on each side here. That should be all I need. And the first thing that you always plot is the y-intercept, because you can't do a slope from a random place. You have to have a starting point. Okay, so my y-intercept, which is 1, will be on this y-axis. I'm going to plot a point at positive 1. And my slope, just like we learned in the last section, is rise over run. Well, 2 is not a fraction, but I can make it a fraction pretty easily by just putting it over 1. So I'm going to rise 2, run 1. So up 2, over 1. Once I have that point, I can draw my line, connecting the dots, and I've got my equation. Okay? Let's do another. Let's do one a little bit tougher. Y equals negative 1/3 x minus 2. Okay? So my slope this time, my m is negative 1/3, and my y-intercept, or my b value, is negative 2. So same thing, I'll put about 4 marks. That should be about all I need. Alright, so the first thing I'll plot is my y-intercept, which again is always on this vertical axis. Y-intercept is negative 2, which means I'm going down 2 units. And my slope is also negative. And what I usually do is I always stick, you don't have to rewrite this, but I always put the negative with my rise. You don't have to, but that's just the way I always do it. So I'm always going to go to the right no matter what. It's just, am I going up or am I going down? So in this case, I have a negative on my 1, so I'm going to, instead of going up, I'm going to go down 1, and then to the right, positive 3 units. 1, 2, 3. Had I put the, had I put the negative with the 3, I would have gotten the same thing. I would have gone up 1, but I would have gone to the left 3, which would have been over here. If you notice, it gets you the same line no matter what you do. So it really makes no difference where you put the negative. I just generally put it with my rise number, which in this case was 1. Okay. So this is how you graph things if it's in slope-intercept form. Unfortunately, they're not always given to you like that. So example 4 in this section is given to you in what's called standard form. Standard form looks like this. It's ax plus by equals c. A, b, and c can be any number, doesn't really matter. So in this case, for example 4, they want us to graph 5x plus 2y equals 10. So my a in this case is 5, my b is 2, my c is 10. Okay? And one way you could do this is you could isolate the y, move the 5x over, divide the 2, and get it in slope-intercept form. But I'm not going to do that. I'm going to find the intercepts. Now, an intercept is wherever it crosses the x and y axis. Okay, and every graph has to do that. If it's got a slope, it's going to cross the x and y axis somewhere. Like these last graphs, it crossed the y axis here, crossed the x axis there. This one you can't see where it crosses the x axis, but you know it's going to because it's got to cross it eventually. So what I'm going to do is I'm going to let x be 0, and I'm also going to let y be 0 because that's where the x and the y intercepts occur. Okay, so this would be my y-intercept. I'm going to the left to right 0, and then I'm going to find out what this y value is. This is my x-intercept because I'm moving up or down none and to the left to right however many units. This is really simple. If x is 0, if I were to take 0 and plug it in right here, 5 times 0 is 0. So that in essence just kind of goes away. And all I have left is 2y equals 10. Well, if I solve 2y equals 10, I would divide the 2 over. 10 divided by 2 is 5. So I've got one of my intercepts. I'm halfway done. Same thing here. If I let this y be 0, if I plug it into here, 2 times y is 0. That pretty much just goes away, and all I have is 5x equals 10. Well, same thing here. If I were to divide the 5 over to the 10, 10 divided by 5 is 2, and that is my other intercept. Once I've done that, just plot the 2 points. 0, 5, which is my y-intercept right here. 2, 0, which is my x-intercept right there. Plot the 2 points, and you're done. Now, just to show you, had you taken this and solved for y, like let's say I moved the 5x over and made it a negative 5x and the plus 10. And I had divided the 2 to both sides, and I would have gotten y equals negative 5 halves x plus 5. I get the same thing. My y-intercept is 5, my slope is down 5 over 2. I just think that this way is a lot easier. You don't have to worry about fractions. You don't have to worry about simplifying correctly. It's just plugging 0 in and doing a one-step solving question. Okay, I'm going to do one more. Let's say I had negative 2x plus 4y equals negative 8. So again, if I let x be 0, let's go ahead and do that first. I'm going to cover up my x value, and I'll have 4y equals negative 8. Well, if I divide 4 over, negative 8 divided by 4 is negative 2. If I let y be 0, which will give me my x-intercept, I have negative 2x equals negative 8. Well, divide negative 8 by negative 2, and you get a positive 4. Plot those 2 points. 0, negative 2 is right here. 4, 0 is right here. And you've got your graph. Takes no time hardly at all.